Hello, everybody, Math 2 students, and welcome to lesson 3.2 and 3.3 all at once. So this will be a little bit longer. And this one is on triangle congruence by Sss and Sas. And what that means is that we can show that two triangles are exactly alike. That's what congruent means. If all three sides are the same, or side, one angle and one side is the same. That's all we need to show. So here it is in the, by the way, we're on page 129. And on the bottom, these boxes are always super important that you look at those. So I'm going to read this one for you. However, this is, no, here we go. Essential understanding. You can prove that two triangles are congruent or equal without having to show that all the parts, the corresponding parts, are congruent. In this lesson, you will prove triangles congruent by using either three pairs of corresponding sides, or two pairs of corresponding sides and one pair of corresponding angles, which sides is SSS and this one is SAS. Notice that if you look at these two pictures, we got two triangles. Now remember the little tick marks here are sides that are congruent, and the little bows demonstrate angles that are congruent. Yeah. So remember, tick marks show sides and the bows show angles. Okay, that's how we can tell they're congruent. All right, we're going to the next page. And what are we doing on the next page? We're reading on the top. We're on page 130 on the top. This is a postulate. And I'm going to read this first right here. A postulate is an accepted statement of fact. The side postulate is perhaps the most logical fact about triangles. It agrees with the notion that triangles are rigid figures, meaning you can't bend them or change them anyway once they're put together with three corners meeting, right? Their shape does not change until pressure on their sides forces them to break. This rigidity property is important to architects and engineers when they build things such as bicycle frames and steel bridges. Triangles are rigid. Okay, so let's read this postulate. Again, make yourself some notes to read this again. It's called the side, or short SSS postulate. It says, we just talked about it, if three sides of one triangle are congruent or equal to the three sides of another triangle, then the two triangles are congruent. Yeah, and the way that it's written is side AB congruent to DE, side BC congruent to side EF, side AC congruent to DF, and therefore the two triangles are congruent. Okay, that's what SSS postulate means. And let's look at this first problem on this page using SSS. And so given information is right here. We got BC congruent to BF, BC, and it's already marked. I need to make that thinner. It's already marked with our little tick marks for us. And CD is congruent to FD, those are sides, and it's also congruent, already marked. Now we're supposed to prove that the two triangles are congruent. Here's the deal. What else do you need to show to prove that they're congruent? Well, we only got two sides. We need a third side. Well, look at the two triangles. They share a side. The side they share is never marked. You got to mark it yourself. So you need to write that. BD is congruent to BD to itself makes sense, right? Because it's the same side for both triangles. And that's called reflexive property. Something is equal to itself, it's reflexive. So remember that from your rules. I think we went over those. And now that we know three sides are the same, 1, 2, 3, 1, 2, 3. So we showed the triangles are congruent by SSS. Okay, but you do need to mention this last side. You cannot just overlook that. So that's what a proof does. You got to list them all. And I'm skipping to the next page, which is, I don't know why this came. I didn't want to do that. This is page 131 on the bottom. Now we're looking at the SAS postulate. Now, the part about the SAS postulate that you have to remember is that the angle, that one angle that's in the postulate, ACE angle, right? Side angle side. Oh, it's written right here. Side angle side. The angle has to be between the two sides. That's the thing about this postulate. Notice the two sides are these. The angle is between. Angle A is, it's called included or between the two sides. This is the angle that will work, not this one or this one. Okay, so you can also show relationship between a pair of corresponding sides and an included angle. It's super important that the location of that angle has to be between the two sides. The word included refers to the angles and the sides of a triangle as shown at the right. Well, they're also showing you the BC is a side that's included between two angles. But for this postulate, I want you to focus on the angle that's between the two sides. So read this and this when you study or do your homework. Postulate: if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are automatically equal, congruent, right? Notice when we have our picture here, you got side, side, included angle, side, side, included angle. Okay, if this is the case, you have proven that the two triangles are congruent. So let's look at an application on this on the next page. It's page 132. Nope, we're on the wrong one, this one. Problem 2. Yeah. Okay, we're doing problem 2 using SAS, and it's going to ask you what other information do you need to prove that the two triangles are congruent by SAS. Notice we got two triangles and they're named for us. L goes with B, E goes with N, and B goes with L. Are there two? B goes with L. So the way they're listed is the corresponding parts, like these correspond, this corresponds. And notice anytime, listen guys, anytime a side is common to both triangles, you have to mark it yourself. This slide, LB, is common to both sides, to both triangles. So you need to mark it yourself, don't overlook that. And we got this angle and we got this angle. So what else do we need? We got a side and an angle. What else do we need? We got side and angle. We need another side. Which side? Is it important? Yes, because our angle has to be included between the two sides. So we need this side LE and this side NB to prove it. So we're going to write, you need to show somehow, you don't know it, that sides LE and NB, so LE and NB are congruent. But there's no indication that those sides are congruent. The only one I know is LB is congruent to itself. We got the angles congruent. And one side, which is LB congruent to itself. So all you need is this third part, which is these two sides. Now, again, you have no indication that these two sides are equal. There are no markings. It's not given. So you would find that this is almost impossible to prove congruent because there's no indication that LE is congruent to NB, but that's what we would need. The question is, what do you need? What more do you need? You need these two sides because we have the angle and we have that side in the middle. And then on the bottom here, these questions are the same. What other information do you, if any, do you need? Sometimes you got them all to prove the two triangles congruent by SAS. Explain. Okay, so what do we have here? We got an angle and we got one side. So we need another side. Which side? Not this one, because we want our angle included, right? We would need this side here. This one and this one. But there's no indication that these two sides are equal. I'm just marking them because that's what we need. Yeah, you need some proof that they would be equal, either by the given information or by some other deductive reasoning that can say, okay, they must be equal, but they're not. Given is only this angle and this side. We need sides LG congruent to MN, which we don't know for sure if they're equal. Okay, I want to make sure you understand that. Let's look at this one. We got two angles, we got two sides, should be perfectly clear it's SAS, but there's one little hiccup. The angle is not between the two sides. The angle is not. So this will not work. Now my thing is going out. Okay, this will not work because the angle is not included. Or between the two sides. Okay, so that's this. On the next page, 133, we want to do the practice, number 5. Would you use SSS or SAS to prove the triangle's congruent? If there's not enough information, Right, not enough information. Explain your answer. So when you see something like this, you always mark vertical angles. The vertical angles are never marked. You got to do it yourself. So now you have two congruent angles. You got two triangles. You got two congruent angles. You mark them yourself. This is what you have to do. Nobody will do it for you. So will that work? We got side, side angle, side, side angle. Side, side angle does not work because you want the angle in between the two sides, right? This, what do you mean? If there's not enough information, but it's not enough information. Not enough information because angle is not included or in between. Or between the sides. And on this one, you notice we have one side that's common to both triangles. Your job is to mark it. You already got one tick mark. Now you have to use two. Side, angle, side, side, angle, side. This would work. Side, angle, side, side, angle, side. Okay, on the next page, we're having our homework. And we're going to move on to the next lesson. This is page 134. And you're going to do number 7. Triangle PEN. Always draw the triangle. Name it however you want. And then you can answer the question. Name the angle that is included between the given sides. Between side PE, this side, and EN, the angle is angle E. So if you draw it out, it makes a visual for you to answer the question. And so on and so forth. You do 7A, 7B, you try that yourself. And then in number 8, again, draw out your triangle, label it HAT, and see where these angles are located, between which sides. Remember, we name sides with 2 letters, we name angles with 1 letter, putting the angle symbol in front. So and then number 9, you name the postulate. It's either SSS or SAS. Those are the ones we learned so far. Remember to mark your vertical angles. Mark your sides that they have in common. You've got to mark these yourself. Number 11, 9 and 10. Number 11. Number 12. There's an error. You find the error and explain. Number 13. It's a little tricky. Number 13 is a little tricky one. And then that's it for this homework. Nope, I'm sorry, I apologize. One more on the next page. You have number 23, 24, and 25. 23, 24, 25. Okay, that's the one where you have to decide, are they congruent? If not, not enough information. What other information would you need? So there's a few parts to that question. First, you say, yes, you can prove it, or no, you can't. Not enough information. What more information do you need? So you got to make sure you answer all the parts. Okay, we're moving on to 3.3, Triangle Congruence by ASA or AAS. Now, these are the 4 that you need to know. You need to know SSS, side angle side, and then you need to know ASA and AAS. Those are the other 2. So go back down here to your box. Let's read. You already know that triangles are congruent if two pairs of sides and the included angles are congruent. You can also prove triangles congruent using other groupings of angles and side. You can prove that two triangles are congruent without having to show that all corresponding parts are congruent. Again, you can show all three sides, all three angles, but we don't have to. We can use three parts only. Got to be the right three parts though. In this lesson, you will prove triangles congruent using one pair of sides and two pairs of angles. And there we are, postulate 16, angle, side, angle. The two triangles are congruent if you have an angle, the included side, the side between the angle and another angle. Do you see how that picture is? It has to be the side that's between the two angles. So just not any willy-nilly side, okay? And that's called ASA. And then let's do a couple practices. Let's go to the top. Which two triangles are congruent by angle, side, angle? So let's look at these. There's one out. One is out. Which one is out? This one is out. These two are in. When you use ASA, what must be true about the corresponding side? It must be included or between the two angles. Okay, so we try explain. Okay, the side is between the two angles. Okay, this is not. The side is on the outside. See how these two angles and then this one is on the outside. Let's try one more. Name two triangles that are congruent by ASA. It would be, this one is out because that side is not between the two. It's this one and this one. So much fun. Let's do the last one. Which one is out? Angle, side, angle. Angle, side, angle, side. This is side, angle, side. But they ask us to show by angle, side, angle, remember? So this one is out. It would be this one and this one. Angle, side, angle, angle, side, angle. They're giving us extra information on that one. Okay, next page. We're skipping page 140, going straight to 41. So now the last postulate, this is a theorem. So the other three were postulates. This one had to be proven. Once you prove in that one, all the postulates use this theorem. No, I'm sorry, the other way around. All the postulates don't need to be proven. The theorem uses the postulates to prove that this is true. Theorems have to be proven to be true. Okay, you can use, you can also prove triangles congruent by using two angles and a non-included side, as stated in the theorem below. Angle, angle, side. So let's look at the picture. Angle, angle, side. Notice the side is not between the two angles. It could also be this side, by the way. Angle, angle, nope. Angle, angle, side. It's kind of like you're going around in a circle. Start here, angle, angle, side. Same here. Start here, angle, angle, end up at the side. It's like a rotation. So if that's the case, also these two triangles are congruent. And I'm skipping all these proofs. I'm skipping the next page. We are We are on page 143. This is page 143, problem 4. Yep, there we are. Determining whether triangles are congruent. Are the two triangles congruent? Explain. Now, remember, what's the first thing I do when I see this kind of layout? I'm marking my vertical angles congruent. That's the very first thing you have to do. Nobody will do that for you. If you don't, you're going to get it wrong. And why do I have to take more than one bow? Why am I using two bows? That's a good question, huh? This is because the one bow is already taken. Okay, so you got your vertical angles. Now let's look. Angle, angle, side, angle, angle, side. Yes, those are congruent. Yes. Because, now let's talk about the vertical angles. We need to name those correctly. How do we name that angle? If I call it angle R, is it sure which angle I'm talking about? Could I mean this one or this one? So when there's an ambiguity, meaning you're not sure which angle R you're talking about, you got to use 3 letters. So we're going to use angle P, R, A. P, R, A is congruent to, what's the other one? IRS, angle IRS, because they're vertical angles. Now, come on. It's not letting me. Vertical angles are congruent. So now we have angle, angle, side. Yes, congruent. Yes, congruent by angle, angle, side. But we have to bring this up. We have to make sure we understand why we mark these two equal. So you have to talk about vertical angles and name them to be perfect, okay? So now we're going to the next page, 144, and we're almost done. 144 on top. So it's asking, determine whether the triangles must be congruent. If so, name the postulate or theorem that justifies your answer. If not, explain. So remember, I'm going to give you a review which ones are allowed. Side, 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 angle, side, angle, side, angle, and angle, angle, side. This one is not or backwards. This one does not work. Okay, these two are often cited by students, but they don't work. These are the only 4 that work to show two triangles congruent. Okay, this is something you need to memorize, okay? So let's look. What are we marking? We got to mark the one side they both have in common. So yes, they are congruent by angle, side, angle. Okay, because you can always name MO congruent to itself. And the last one here is weird because you got these arrows. Remember, the arrows mean we got 2 parallel lines in the transversal. So whenever you see parallel lines, you think of alternate interior, alternate exterior angles that we learned about. So you can mark this angle and this angle. Those are alternate interior. So these are congruent. So we have angle, angle. Do we have a side? Yeah, there's a side. Angle, angle, side. Angle, angle, side. So yes, by angle, angle, side, because angle UTS. So I'm naming this one UTS, congruent to RST, angle RST, by alternate interior angles theorem. Yeah, alternate interior angles are equal if the lines are parallel. And we also have to mention TS is congruent to itself. Reflexive property. And that kind of clinches the deal that we can say angle, angle, side, angle, angle, side. The two triangles must be congruent. And that's it. Now your homework is, I'm not giving you a whole bunch, so you have 2 lessons. So number 9, again, draw it out. Look at the picture, triangle RST. And you can figure out which side is between R and S. That's angle. Which side is between these 2 angles? Well, it's this one, side RS. So I'm giving you the first one. Okay. Number 10, your job to do. And then go to number 11. Okay, which postulate or theorem? Remember the choices. ASA, AAS. Those are the choices. Write them out as much as you can so you remember. Number 12. Number 13. Compare and contrast. How are they the same? How are they different? Error. Always looking for an error here. Explain where the error is. And then I have on the next page, we have number 15. Draw it out. This is going to be the hard one, but draw a picture, 2 triangles, call them FDE and GHI, and then see what you got. Is this given? What else do you need? And this one is your think about a plan. So you're looking for a treasure in your garden. You got to follow these instructions to draw the diagram. You can draw it right here and answer the question. See if you can do that. And that's it. Good luck, guys.